New planet made of ice discovered. It's a mini-Neptune called Kepler-10c, the planet that changed everything. We thought we knew about worlds beyond Earth. Back in the early 2000s, space felt simpler. You had your rocky Earth-like planets, your gas giants like Jupiter, and maybe a few icy dwarfs thrown in for good measure. We thought we had the categories figured out. We were wrong. Kepler-10c shattered that illusion. First discovered in 2011 by NASA's Kepler Space Telescope, Kepler-10c started as a dot, just a tiny dip in starlight 600 light-years away in the constellation Draco. But over time, it became something far more shocking. A new type of planet, a cosmic riddle, and maybe, just maybe, the prototype for a class of worlds we never imagined could exist. When the Kepler team first announced Kepler-10c, it came with a sense of triumph. This was no rogue signal or fuzzy image. It was a real planet. It orbited a star like our Sun every 45.3 days. It had a radius about 2.35 times that of Earth. For comparison, that's smaller than Neptune, but far bigger than Earth. Naturally, astronomers thought, Mini-Neptune. We expected a gas-rich world, something with a thick atmosphere, a smaller cousin of the icy giant we all know. Exoplanet Researcher, 2012 press release. That assumption fit the models. Bigger planets pull in hydrogen and helium from the solar nebula. That's how gas giants form, right? But Kepler-10c had other plans. A twist in the tale, mega-Earth or icy water world. Then came the HARPS North instrument. Precision, clarity, and a revelation that rocked the scientific world. Kepler-10c was far heavier than expected. Its mass, once estimated lightly, was now calculated between 7 and 11 times Earth's mass. That gave it a density of roughly 3.1 grams per cubic centimeter. Too dense to be a typical mini-Neptune. Too light to be a giant rock. Too massive to be a fluke. Something was off. Or rather, something was new. Theories exploded. Was this a mega-Earth? A water world? Could it be both? Turns out, it might be neither and both. A planet rich in water and volatile materials, but without the thick gas blanket we see on Neptune. A world of oceans, high-pressure ice, and unimaginable geology. Kepler-10c might be an icy water world with differentiated layers and a structure never before seen. Planetary Scientist, 2014. For years, space lovers and scientists alike fought to name this world. What is a planet that defies the known categories? It's not a super-Earth. Too heavy. It's not a mini-Neptune. Too dense. It's not a gas giant. Too small. It's not fully rocky. Too volatile rich. So, we created a new idea. An icy water world. Something between myth and science. Theorized, but never confirmed. Until Kepler-10c. This planet forced the scientific community to throw out the old checklist and start again. And that's not just exciting, it's revolutionary. Deep dive. What is Kepler-10c made of? Let's get specific. Based on models and density, Kepler-10c is likely structured like this. A thick layer of water or high-pressure ice, possibly hundreds of kilometers deep. Beneath that, a dense, silicate-based core similar to Earth's mantle. Above it all, a thin atmosphere, possibly water vapor, but not hydrogen or helium. Its temperature? A toasty 584 Kelvin, that's over 600 degrees Fahrenheit. Far too hot for surface ice, but with enough pressure. Water behaves differently. It becomes supercritical or transforms into exotic ice forms that don't exist on Earth. In short, Kepler-10c is alien, but fascinating. When the full data came out, reactions were intense. NASA, Harvard, ESA all took notice. Kepler-10c is a game changer. Dr. Dimitar Sasolov, Harvard-Smithsonian Center for Astrophysics. This planet opens a whole new category. NASA Kepler mission lead. It's a reminder that nature still holds surprises. European Space Agency, ESA. This wasn't hype, it was history. Before Kepler-10c, the rulebook was clear. Planets this big must turn into gas giants. Their gravity attracts gas envelopes. They puff up. They lose their rocky nature. But Kepler-10c said no. It told us planets can form with massive rocky or icy cores and retain them, even in tight orbits. It challenged assumptions about planetary formation, thermal evolution, and even atmospheric escape. Kepler-10c has reminded us that in science, no theory is sacred. Astrophysical Journal Commentary, 2015. As telescopes like JWST and Plato gear up for deep space exoplanet analysis, Kepler-10c serves as a reminder. Our models are only as good as the questions we dare to ask. If this planet exists, how many more are waiting to be discovered? Planets with ice oceans boiling under alien skies, worlds with pressurized cores and unstable surfaces, or planets that could one day host life. That's the kicker. Kepler-10c may be too hot now, but its structure suggests that planets with rich water content can form early and last billions of years. That could mean habitability somewhere else, on another version of Kepler-10c, orbiting farther out. This planet is real, and it's nothing like Earth. Let's start with the basics. Location: about 560 to 564 light-years away in the constellation Draco. Orbit: circles its host star every 45.3 days at a distance of 0.241 astronomical units, closer than Mercury is to the Sun. Size: 2.35 times Earth's radius. Temperature: 584 Kelvin, approximately 311 degrees Celsius. Inhospitable? Yes. But fascinating? Absolutely. The Kepler-10 system, a star with a story. Let's zoom out. Kepler-10 is a G-type main sequence star, similar to our Sun, but significantly older. It hosts at least 3 confirmed planets. Kepler-10b, a hot, rocky world extremely close to the star, with an orbit of just 0.84 days. Kepler-10c, the volatile-rich exoplanet in question, orbiting every 45.3 days. Kepler-10d, a more recently confirmed planet with a minimum mass of approximately 13 Earth masses. It's a compact, ancient system full of planetary variety, a snapshot of how wildly different planetary outcomes can be. When Kepler-10c was first unveiled at a conference in 2014, NASA scientists called it the Godzilla of Earths. That nickname stuck for good reason. As theoretical physicist Dimitar Sasolov said, "This is the kind of planet we didn't know existed. We thought that a planet of this mass would pull in hydrogen gas and become a Jupiter-like gas giant. Kepler-10c didn't. It's solid, like Earth. This is the Godzilla of Earths." Such strong words from leading minds carried a message. We're just beginning to understand what planets can be. Kepler-10c looked at first glance like a textbook Mini-Neptune. With a radius just over twice that of Earth's, 2.35 times to be exact, it should have been a fluffy, low-density gas envelope wrapped around a rocky or icy core. That's what all our models said. That's what we'd seen before. But then scientists measured its mass, 11.3 Earth masses. And the numbers didn't add up. Planets with that size and mass weren't supposed to exist, not without a thick gas blanket. Yet Kepler-10c showed no sign of one. Instead, its density, about 4.75 grams per cubic centimeter, was way too high for a mini-Neptune and far too low to be a gas giant. That moment wasn't just a surprise, it was a paradigm shift. Struggling to classify exoplanets? You're not alone, so are scientists. Kepler-10c exposed a crack in the foundation of planetary classification. Until then, astronomers had trusted something called the mass-radius relationship, the idea that a planet's size and mass could predict its composition. If it's big and light, must be gassy, small and heavy, rocky. But Kepler-10c flipped that logic on its head. It proved that planets with Earth-like densities could be much larger than expected. It defied labels like super-Earth or mini-Neptune. Scientists had to invent a new term, mega-Earth. This planet wasn't gas-dominated. It wasn't even rocky in the classic sense. It might be something entirely different, a volatile, rich world with deep oceans, thick layers of ice, or high-pressure water phases we've never encountered. The first super-Earth or a super-illusion? Kepler-10c orbits a sun-like star about 560 light-years away, and at first it seemed too good to be true. It was large, dense, and in 2014 labeled the Godzilla of Earths due to its massive size. Scientists were amazed. Here was a planet that defied our understanding. It was thought to be a giant ball of rock with 10 times Earth's mass. This announcement sent ripples through the scientific community. If a planet that big could still be rocky, then maybe habitable Earth-like worlds were far more common than we imagined. But science doesn't stop at first impressions. The temperature that killed the dream. Let's get to the hard truth. Kepler-10c's equilibrium temperature is about 584 Kelvin. That's 311 degrees Celsius, or 591 degrees Fahrenheit. That's not just hot, it's oven hot. The planet orbits its host star at a blistering 0.241 astronomical units, less than a quarter of the distance from Earth to the Sun. That puts it deep inside the inner edge of its star's habitable zone, which begins around 1.1 astronomical units. Translation: this world gets way too much radiation for liquid water to survive on the surface. And where there's no liquid water, there's no life, at least not as we know it. That alone rules out any conventional habitability, but there's more. The ice planet that's too hot for ice. Here comes the emotional twist. What if I told you Kepler-10c isn't even rocky? Despite early reports, more precise data revealed something surprising. Kepler-10c is not a solid, rocky world, but rather a volatile, rich planet, composed mainly of water and exotic forms of ice. Sounds promising? Not quite. We're not talking about cool, drinkable water or pretty frozen lakes. We're talking about superionic ice, a bizarre form of matter that exists only under crushing pressure and intense heat, deep below a planet's surface. According to internal models, up to 28% of Kepler-10c's mass and 29% of its radius is made up of this high-pressure water, locked away under conditions alien to anything earthly. On the outside, it may have a volatile envelope of hydrogen, helium, and water vapor, but even that is likely thin due to the planet's old age and harsh proximity to its star. It's an ice world with no cool comfort. You've seen the evidence. Now let the truth inspire you. Kepler-10c is not what we hoped for, but maybe that's okay. Because hope isn't about easy wins. It's about continuing the search, about looking again, deeper, smarter, about learning from every star, every orbit, every atmospheric spectrum. So if you're the kind of person who believes in truth, discovery, and the journey ahead, take this as your sign. The universe is still out there, and the next habitable world might be closer than you think. You've followed Kepler-10c's story to the end. Now keep looking up and imagine what's next.